By the end of this talk, what I'm aiming for is that you would know the single biggest reason air pollution interventions fail to prove their health impact, and how do we, going forward, fix it for the climate transitions ahead of us. It is not bad policy, it is more about missing data and lack of the suitable measurements. So, the reason that we have missing data is because there is a long chain. So think of it this way. Or let's say imagine a city bans its dirtiest diesel trucks. A year later, do fewer people end up in hospital with breathing problems? That sounds like a simple enough question with possibly an obvious answer. But actually it is very hard to connect those two dots. So let's say a policy is introduced. The emissions fall, air does get cleaner, everything walks out, people are less exposed, and then health would start to improve. The thing is, in most practical situations, we stop measuring at the second step. Emissions fall, that was the goal of the policy. There isn't enough detailed examination of what happens in terms of exposure and subsequently health impacts. So, a systematic review in 2020 examined or went through 28,000 studies, and they found only 42 strong enough to learn from about the impact of clean air policies on actual health of the population. The surprise at the heart of this talk is that the evidence problem is not just scientific uncertainty, but it's missing data because the evaluation is often not part of the intervention. That's what I would like to call the long shadow of health. Health effects take uh, years to appear, and there are dozens of other factors which are competing for the explanatory space. So when a policy passes, you have a pretty immediate linkage possible to the emissions. But from the emissions to health, unless you have a mechanism in place to carefully monitor and connect the cause and effect, it's difficult to directly prove this. Let's have a look at what the data says in terms of what actually worked. So first, let's look at the smoky coal bans in Ireland. This took place around the 90s when Dublin banned the sale and burning of smoky coal. Respiratory hospital admissions dropped, and similar bans in other Irish cities, counties, they were linked with reductions in cardiovascular and respiratory hospitalizations. Similarly, when Japan modified their transport standards, diesel vehicle emissions for trucks entering Tokyo, they had to be cleaner, and that was associated with reductions in all-cause cardiovascular and respiratory mortality. So tighter standards for diesel trucks led to reduced respiratory symptoms among children, among hospital admissions. But there is a tendency for this picture to get complicated pretty fast. When London's congestion charges were applied, they did not show any clear change in the pollution concentrations. Low emission zones across several European cities have been applied, and they show modest to inconsistent effects. And worst of all, the Mexico cities even odd driving restrictions. This might even have raised the pollution a bit because possibly some households who had to travel for work bought second cars to get around the rules. Industrial interventions also showed mixed results. Some factory closures, power plant conversions improved air quality, and a copper smelter closure in the US Southwest was associated with lower all-cause mortality, but overall certainty of evidence across the different types of interventions was rated low. So the honest admission in the article is that researchers were trying to evaluate policies that were never designed to be evaluated. Monitoring systems were built for regulations, not for proving health impact. So while health data might have been collected for an entirely different reason, that was used to kind of indirectly look at the impact of this clean air policy on the outcome. And that's what made joining the dots so complicated. So what is the fix? The answer would be to embed evaluation from the start of the implementation of the policy, not retroactively, but proactively. One of the first things is like placing air quality monitors where people actually spend time, and not only on roadside compliance stations. It means linking health data to exposure as closely as possible. It means treating clean energy and clean transport transitions not only as engineering projects, but also as public health concerns. So, if you do not build evaluation into the intervention from the start and try to use data on health that was gathered for some entirely different objective to prove your point that clean air policies help with exposure, reduced exposure, improved health outcomes, you would often be missing a link in the chain. Now, why this is particularly important at this point in time is because of the climate transition, which is also an air quality transition. Like when we're switching from, let's say, gas boilers to heat pumps, it removes combustion sources from the homes. Electrifying the transport network removes exhaust pollutions at street level. Expanding cycling infrastructure reduces vehicle kilometers. In effect, we are kind of running the largest coordinated air quality experiment in human history in our effort to curb the emissions and the climate challenge. And the article's warning is simple. If these changes happen without proper evaluations, we may improve the air without ever fully knowing how much health advantages we gained. So, every climate policy is a public health intervention in effect. So, my aim in this video, this is threefold. First, the diagnosis, the evidence gap is really a measurement gap. Second, the proof that some interventions do conclusively save lives, including things like the Irish smoky coal ban, Japanese vehicle standards. Third, the practical lesson, if evaluation is not built into intervention design, the chance to learn may be lost. So the next time an air quality intervention is proposed, funded, or assessed, the question should not only be does it reduce emissions? The question should also be does it allow to measure whether health improves? So for that you need placing sensors where people actually spend time, linking health data to pollution exposure at individual level, and At a policy level, we want to treat the clean energy transition, the climate transition, as a public health trial for the future generations to come. This is how we can have cleaner air becomes a proven public health gain. And considering the kind of transitional period we are in, we have kind of one shot to make this happen. We cannot waste it by failing to measure what matters most.